acceleration, this is constant acceleration formula, and it's accelerating at 0.2 meters per second squared and for 5 seconds. You just have to find the distance after these 5 seconds. We just plug it, and it starts at rest, so 0. It comes to 2.5 meters. Next, we find the tension in the coupling, the first one. For that, we just need the F net equals driving force minus tension, and F net is the total mass. There's two masses of 10 tons and one of 40. Is the total mass is 60,000 divided by 0.2, and then the engine is 40,000. T, and T comes to minus 4,000. You don't really need the direction, so you can just put 4 newtons. The locomotive at a constant 4 meters a second when it collides with stationary trucks each with mass 10. So this is momentum conservation question. P initial equals P M1 U1. And then it's just total mass of the other one. So the engine is, again, we have 40,000. It's going at 4 meters a second. And the total mass is 80,000. We have 4. And V1 comes to 2 meters per second. The collision between, so elastic or inelastic, so we're checking if the kinetic energy is the same before and after. So the kinetic and the initial kinetic energy squared of times 80. Oh, 4,000 times 4 squared, which is 300,000 joules. And after the collision, mass is 80,000. We got the velocity in the previous question. So in this case, it's not elastic because EK initial does not equal EK final. So we have a spring question. So for this one, this question, it's just the F equals X. And for F, you just do M. Mass for the first one is 0.5. Okay. The difference is 0.1 meters. that should come up to for this one, there's a variety of methods to do it, but I'll just go with the first one. We can find the midpoint again using f equals kx. H 40 centimeters. So for 50 gram masses is 0.2 kilograms. 10 for the acceleration. K we found is 5, finding x. So the extension is 0.4 meters. This is the midpoint. So for the lowest point, you just add another, since it's symmetrical, you add another 0.4 meters. Oops. Explain why Joe is incorrect. So in this question, they're only using, in their calculations, they're only using spring potential and gravitational potential and not kinetic energy. So explain why Joe is incorrect. Joe is the total energy has to include energy to be add to constant amount at point. Calculate the maximum speed of masses during the oscillation you're working. At the highest point, it's just gravitational potential. So, and then in the middle, we'll have gravitational potential and spring potential and kinetic energy. Of kx squared plus half me squared. So for the first gravitational potential, mass, here are the masses, 0.2 it's still. It's 10, stretch, it's at it's at 0. And for this, in the middle, it's 10, 0.4, which we calculated before. Off. It's stretched by 0.4 at midpoint. That's a 0.2 and v squared. I won't go through all of that, but v squared equals 4, so equals 2. meters per second. These questions. Angle is 30, speed is 20 meters per second. Calculate the maximum height. Again, it's constant acceleration formula. E squared equals U squared plus 2AS. Since find the maximum height, V will be 0. And AB is in the horizontal, vertical speed. And T sine squared plus 2 minus 10. Finding S comes to 5 meters. Later, the path will hit the X. So get to here, 26 meters. So we can first find the time taken horizontal using horizontal speed. S equals ut plus t squared. It's 26 meters, and the initial speed horizontal axis is 220 cos 30, and t this is 0. T comes to 1.5 seconds. Next, we just had to find h. So x equals ut plus half at squared. X equals, and then vertical 23.5 half is 10 5 squared to 3.75 meters at h. And we're going to centripetal forces. The minimum speed at which Mary and Bob must be at a point A for them to feel weightless. So there's no normal, they won't feel any normal force. At this point, it'll be mg equals F net will equal ma. M squared R equals ma. This will come to, you might already have this formula, V equals Rg. The radius is 20 meters multiplied by the gravitational acceleration comes down to 14. Excuse me, 1 again. Explain why Mary and Bob feel weightless at point A. So feel weightless. Must experience normal force. We always had to talk about normal force, weightless questions. So at this point, they have mg and the f net. At this point, appearance is, correct me if I'm wrong, is out by fourth. So is appearance Harry and Bob feel parent eggless. Assuming the track is frictionless, all the forces. So we have always the gravitational force G or Fg. We have normal force which is equal to the G force, and we have the centripetal. This is the net force. I'm going to gravity stuff. Planet's orbit is 1,200 hours. Orbit is measured to be 7.10 to the power 10 meters. First, we have to find the period in seconds. There's 2 equals 200 times 16 times 60 again. And then it's the Kepler's law. And then we're finding the mass. So T squared. And then we just plug everything in. 4 times pi squared times orbit is 7.0 times 10 cubed. That would G. T we got 4, 6 squared to 1.1 times 10 to the power 31 kilograms. Yep. Is it possible to determine the mass of this planet from the data above? Give a reason for your answer. So we're only given the planet's circular orbit and we're only given the period and the radius of the orbit. And when we're to find the mass of the planet, there'll be this mass in there as well, which will cancel out, but to write this. So the radius orbit independent of the planet's mass is not determine it from it. Or you could probably also use like the formulas to show that the masses cancel out. Oh, we don't do that in this. Electric power. Which one of the following best describes the direction of the magnetic field? Point X. So we just use the right hand grip rule. Way. So, oops. I don't know what let me type, but should be left. So let me type some. I'm gonna stop sharing for a second. What's going on? Oh my god. There you go. Hey. Which of the following best describe the direction of the force on the wire? Point X. Now it's right hand palm rule. So the direction of current is this way, the force is this way. Out of the page. Horizontal square connecting one is placed in uniform field. So it says choose one or more. So there's a good chance there's more than one answer. So discuss different methods of causing a current to flow in the loop. Choose one or more. Moving the loop directly upwards doesn't cause flux change, so it can't be that. Now sideways to the left, but keeping it completely inside also doesn't cause flux change. Moving the loop sideways to the right so that it moves out, so got that. And rotating it, some of it goes out and a different area changes. So this also works. See Andy. Uniform field of the magnet. Calculate the resistance of the loop. So we have to find voltage first. Find the EMF. It's minus N flux change over time. It's just one turn. So we have 0.05 as the field strength multiplied by the area. It goes to 0, so we just need this first one. And it does in 10 milliseconds, 10 times minus 3, which comes to 0.4 volts. And you should always just know this formula. R equals V I 0.4 over, they gave us the current 0.02, 20 ohms. Magnetic field is reduced to 0, indicate the direction of the resulting current. This is all Lenz's law things and right-hand grip rule. So the current going in is decreasing. So we need to induce a magnetic field going in as well. To do that using right-hand grip rule, the current will be going clockwise. According to Lenz's law, induced current will travel direction that it creates magnetic flux in direction that opposes the change. In that direction. Flux that the change in flux that created it. In this case, there is a reduction of flux into the page, using grip rule. Must DC. I don't know what else to say. AC voltage, the primary call AC RMS 400. So 1130 the ratio is 130 over 200, which is 240. This is in secondary coil. VRMS in primary would be 10 watts. We peak, find root 2 times ARMS, which is root 2 times 10.1 watts. The wires have a total resistance of 5 ohms. The light bulb is designed at 6 volts. There's 1.5 resistance. That's produces 13 watts. Calculate the voltage loss if the voltage emitted at the light bulb is 3 watts. Just in drop would be the initial voltage, which is 13 watts. And you just find the difference in watts. Just be 10 watts as the voltage drop. Power output, need to find, I don't think you need to find count first, but I did. This is for at the light bulbs, which is voltage is 3 at the light bulb, and the resistance is, we got 1.5. They give us 1.5 to 2 amperes, and power is P equals VI. We have the voltage, the current, 6 volts. I think you can just use P equals V squared over R for this as well. Calculate the current flowing in the long connecting wires. We found the V drop equals 10 watts. You can just use that, and the resistance of the long connecting wires is 5 ohms. And I equals R 10 5, which Chama knows that the more brightness can be achieved if you set a DC supply to the higher constant voltage. However, she also knows that it's unwise to run the light bulb at greater than 6 volts, as it will probably fail. So calculate the greatest voltage that Jemima can set the DC power supply at without exceeding 6 volts across the light bulb. For 6 watts at the light bulb, we can find the current first. I equals 0 R. You know that the resistance is 1.5, and we're giving 6 watts this time. So throughout the whole circuit, it'll be 4 amps. And then the V drop across the wires will be IR, and at the wires it's 5 ohms. So 4 times 5, 20 watts. And we need 6 watts at the light bulb. So we have 20 watt drop, and it has to be 6 watts there. So we supply is 20 watts plus 6 watts, could be 26 watts at the power supply. Efficient transmission of electric power system will use a step up and step down. The use of transformers reduces transmission. Okay. Transformers maintain power during perfect transforms. I'm doing this step up and step down process. In the step up process, voltage is increased maintained as P equals VI. Current is decreased. This allows for less power, which is what it's asking for. This allows loss as P loss equals IR. $75 a while. Length 40, 15.2. For part A, it's all right-hand palm rule at WX. Here, north, using the right-hand grip rule, it's down, and in the parallel sides to the magnetic field should be no force. The same for force, and then using right-hand palm rule again, up Y to Z. What is the magnitude of the force? So F equals N BIL, 75 turns. The magnetic field is 0.02. Current, I guess, is 2. The length is 0.4. Gives us a total of 1.2 newtons. Motor is switched on when the coil is stationary. Coil starts to rotate. Okay. This causes an upwards force at YZ, and downwards force at XW. I'll probably don't write this right when the motor is switched on. Providing, I don't know if you have to talk about torque, but torque which rotates the coil. If you want a diagram, it's just one side it's going up, so it's going down. Causes to rotate. As the coil rotates on the side of the child to the vertical position when its plane is perpendicular to the magnetic field. The table below indicates the direction of the current inside WX. There is current these positions. WX is this side. It's rotating now. To start for the vertical position, current is going from W to X, which they've given us before. If you look at the diagram, current is going that way. The vertical position, so it's completely vertical. Since we're using a split ring, there won't be any current going through it. And then split ring commutator then switches the direction of current. So then it will be from X to W. Spin also shows an AC signal. This would be expected because they're using slip rings. It's a generator, right? Uses slip rings. For a constant connection with coil. This provides a current that changes direction. Split ring would be heated, change the current every half turn. That so that it that the produced current is the same direction. I think you can write more about that. Not really sure. Coil generator makes 1/2 turn every 25 milliseconds. Frequency. Frequency period. Period. In this case is double the 25 millivolt period first. 2 times 50 milliseconds. 50 times 3. Frequency value of 20 hertz. This increase so the eclipse completes 1/2 turn every 10 seconds. So this will increase it. You look at the formula. So by speed of rotation, if the speed of rotation is increased, the change in time is down, so the rate of change is increased. Rate change is increased. Is going to go to light and matter. Difference, part difference. It's a white band, so E equals n lambda. It's 1 2 second 0 1 2 second white band. Your wavelength 420. 840 meters. To repeat the experiment using light for different wavelengths. Now it's a dark band, so it won't be immediately know. That's half. And it's at the same position. And they're only changing the light, so the path difference will still be the same. 840. And we know it's the second dark band. Oops. Minus wavelength. And then you start finding the length, which is 560 nanometers. How to find the work function for the metals in joules. There goes Planck. So have we have the incident frequency, which is 1.8. Incident frequency. Work function is also S. HF. Incident frequency. We have H 6.63 times 10 to the power 34. And then the incident frequency is 1.8 times 10 to the power 15. Gives us the value of 1.19 times 10 to the power 18 joules. intensity is increased, experiments repeated with the same frequencies. So in find the graph of frequency gain maximum second is exactly the same as for the first experiment, which is what you'd expect. Explain why this provides evidence for the possible like nature of light. So we can first disprove the wave-like nature. So in in the wave theory, wave theory of light. Emitted electron energy, because they're talking about the maximum kinetic energy would be linked to intensity. And for the particle model, for model electron energy is dependent on frequency alone. On frequency, not intensity. Frequency dependence is by the experiment. Toy is doing some experiments on the diffraction of photons using a beam of photons with an energy of 0.1 electrons. So photon energy is E equals Hc lambda equals Hc. E we have 4.14 times 10 to the power minus 15 times 3 times 1. Energy is 4.1 lambda c. Beam is incident on a small circular aperture diffraction pattern. Corresponding rings in the second diffraction pattern would have diameters that are so that has a large diameter. And using the extent of like the fringe spacing formula, you know that it'll be smaller than or the extent of diffraction, either one, you get smaller than the rings in the original. So give you a reasoning. Extent of diffraction is for the slit size, it's inversely proportional because instead of changing the slit size, you should mention that. inversely proportional to slit size. Increasing slit size decreases the extent or you can say spread. Spread is proportional to lambda over slit size. To compare X-ray of diffraction of X-rays and electrons. So they're very different diffraction patterns. Different spacing in the same energy. We know that diffraction is dependent on wavelength, not energy and momentum. Spacing is dependent on wavelength, particles, energy. Equal energies. The electrons have different wavelength and different spacing will occur. Energy levels. For one unknown one. Explain why a mercury atom while in the first excited is able to absorb 1.8 electron photon but cannot emit. Its first excited state is here. Absorbing 1.8 photon. The electron can do number 6.7, 4.9 plus 6.7, 1.8, 6.7. Electron jumps to the discrete energy level at second excited state. So for it to be able to emit the 1.8 electron photon, it needs to be a discrete energy level at 3.1 electron volts, which is atom doesn't. Emit photon must be energy level at 3.1 electron volts, which is atom max. In a sample of excited mercury atoms, all of the energy levels shown in figure 33 are occupied. So X electron volts and the emission spectrum 0.9, 1.5, 2.2. I just use trial and error for this. I'm not sure if there's any better way to do it, but eventually figured out that 10.4, which is the highest one, minus 1.5 is 8.9 electron volts. And then the 9.8 electron volt one, yeah, it's pretty easy to guess. If you do 0.9, you get 0.9 electron volts. And then the energy level below the X is 6.7. That one plus 2.2, give you 8.9 electron volts. So X 8.9 electron volts. According to one model of atoms, electron and atoms move in stable circular orbits. Electron is moving at 2 times 10 to the power 6. Take the mass of de Broglie wavelength. Okay, this is this wavelength equals de Broglie wavelength. H over momentum 6.63 times 10 to the power minus 34. Gives us 0.36 nanometers. And for the wave used to explain the quantized. Okay, we're talking about standing waves now. Electrons form standing waves. Waves around the nucleus. Which is wave. I'm just putting this in here because it's asking what the wave nature of electrons. So only certain orbits of certain currents equaling, equaling to a whole number of wavelengths allow for standing waves. Each bit distance and energy. So Einstein's special relativity, concept of inertial frame. Okay. Relativistic effects work in an inertial frame. Frame in which all time measurements, proper time. It's not the case. It needs to be in the same frame. There's no acceleration. Yeah, so all laws, all Newton's laws are always obeyed in an inertial frame. A number of experiments have played a part in the history of the theory of relativity. Which one of the following is what the Michelson experiment? More accurate version of the experiment produced results that were significantly different. No, I know it's been the same. It was only ever interpreted as confirming. It wasn't, it confirmed it, but it wasn't meant to. It was designed to prove Einstein's postulate. It wasn't designed to do that. What it did was detect a difference between the speed of did not detect the difference between the speed of light in directions. And 3, a person moving parallel to the length of a 2-meter ruler observes a change in the length of the ruler due to relativity. Okay. So be careful, it says change of length. So the length observed is 1.99. So L equals 0. 1.99 to Lorentz factor. Lorentz factor comes to right. $1.99 to 1.005 1 minus e squared over c squared. 1 over the value we got before. 995. So v squared over c squared is squared minus 1.075. Yes. Two divided by 1.99. And over square root. I got it. .99 minus 1. it equals 0.09 C, which is closest to C. Two spacecraft travel in opposite directions. Both are traveling relative to the inertial frame of the galaxy. 0.5, using the classical understanding, speed of the radio signal relative to Hector. Hector is going at 0.4 C. And away, so you can find velocity will be C minus 0.4 C. 1 minus 0.4 is 0.6 C. Being a relatively Hector, so that's why I use that. Measured in the frame of Ajax, the radio signal reaches Hector at 0.01 second. This is just ET, because we're in Ajax frame. Which is C times 0.01. G is 3 times 10 to the power 6 meters, which is 3,000 kilometers. How can proper time be measured for the interval between the radio signal being emitted on Ajax and the signal reaching Hector? This is like this situation, they're both moving away, and you can't really use the crew on Ajax to measure the proper time, since they're observing something that has special relativity affecting it, and then same for Hector. And an observer stationary will just observe dilation as well. So no single observer can measure proper time in this case. Astronaut takes constant velocity of 0.6. Period of the clock as measured in the moving spacecraft is should be the same. Yeah, it's the same when the spacecraft was stationary. They're in the spacecraft. They're looking at a clock in the spacecraft. Clock was built using 2 mirrors, 5 meters, 0.25. According to the observer frame of our galaxy, the distance between the mirrors is closest to equals 5 over 5, which is 4. From A to B and back A. Another clock. So according to an observer in the frame of a galaxy. So again, this guy. We can find my T for 1 is it's 10 meters. So 10 times C, 10 divided by C. minus 9. Yes, T0 is 2.33 times 10 to the power, given 9 times 1.25. It's 42 10 to the power minus 9 seconds, which is 42 nanoseconds. And just be careful, this is A to B and back to A, which is why I use 10 meters, not 5. And its antiparticle, each rest annihilate to produce 2 prophotons. His total energy is 4.5 times the power minus 11. So we can find the energy for one of them. Just 4.5 divided by 4.5 times 10 to the power of 4.5 times 11 divided by 2 comes down to 4.5. 11, 2.25 joules. And they're at each at rest, they're annihilated, so there's no kinetic energy how to deal with. It's just equals mc squared. M equals c squared. 2.25 times 10 to the power 11 c squared. 2.5 times 10 to the power minus 28 kilograms. Answer B. Power is now accelerated from rest for colliding with an antiparticle. But work is just kinetic energy is to minus 1 c squared. So lambda, the Lorentz factor is 3. It's 1. We found the mass before, 2.5 times 10 to the power minus 28, and c squared. This equals 4.5 times 10 to the minus 11 joules. Yeah, that's all.
Thank you.
Thank you.